Hello and welcome to another session of electronics. Today we will continue with principles of electricity. In the earlier two sessions we talked about these. Okay, just to recollect, charge on single electron is 1.6 into 10 to the power of minus 19. Current can be given by charge by time. Voltage is given as work done by charge, and by Ohm's law these are the three equations. V is IR, I is equal to V by R, and R is equal to V by I. We need all these for problem solving. And resistors in series is nothing but sum of resistances. Resistance in parallel is reciprocal of resistances, and if there are many resistors, all you have to do is add them if they are in series and take reciprocals and add them if they are in parallel. And power can be given as product of voltage and current, and when you substitute using Ohm's law for V, then it will become V squared by R. If you substitute for V is I into R, then you will get it as I squared R. If you substitute for I, which is V by R, it will become V squared by R. So these three equations are also important for us to understand several circuits. Electric energy is given by P into T, power into time. Okay, so this is what we discussed earlier. Today what we are going to do is we'll see what is a DC source. You would have seen all cells and batteries, correct? So what are the types of batteries and cells, and then we will go ahead and see how to represent a voltage source, how to represent a current source, and how to convert voltage source to current source and vice versa, current source to voltage source also. And then we will you will have to understand certain terminologies, and then we'll go ahead with Kirchhoff's laws. Okay, these are the things which we are going to discuss today. Before that, based on what we did earlier, resistance in series and parallel, we will take up two problems and try to see the solution. Okay, so I want you to understand that we need to find total resistance between A and B. So how is the circuit connected? You have to first analyze the circuit for series and parallel combination. If you think of current flowing from here, it gets divided, correct? And this point is same as this point. If you come up here and see, this point is same as this point. So that means these two resistors are in parallel. Similarly here also, this and this point are same, so that means these two are in parallel. So this circuit can be rewritten like this: these two in parallel, these two in parallel, and these two remain as it is. When they are in parallel, it is better to simplify them into one single resistance. Two resistance of equal value, if they are in parallel, then the total resistance will be R into R divided by 2R. Correct? So it is R1 R2 by R1 plus R2, remember? So when you substitute, it will become R by 2. This is also R by 2. When two resistors of same value are connected in parallel, equivalent resistance is R by 2. So this can be replaced as R by 2. This parallel combination can be replaced by R by 2. So rest of them you leave as it is. Now you analyze this circuit. Again, when current flows from here, it gets divided between this branch and this branch. But the same current flows here and here for both the resistors. When same current flows through the resistors, that means both the resistors are in series. Here also same current flows means these two are in series. So you have to add these two, you have to add these two. R by 2 plus R is nothing but 3R by 2. R plus R by 2 is again 3R by 2. These two are in parallel. When they are in parallel, you use the formula R1 R2 by R1 plus R2. When both are equal, it will be divided by 2. One resistance you take and divide by 2. So it is 3R by 2 divided by 2, which is equal to 3R by 4. This is how you simplify the circuit. Okay, analyze this and everything is given. You should be able to understand. We'll take similarly one more. You have to find the resistance between these two endpoints. Though it looks like this, though they look in series, they are not in series actually. So see, the point A is again connected over here, and this point B is again connected over here. Okay, so you can call it as A and A like this, and B can be written B over here. Okay, so now you see, if this is B and this is A, between A and B resistance R is there, between A and B resistance R is there, again between A and B resistance R is there. So essentially what does that mean? All the three are in parallel. Between A and B all the three resistors are there. So three resistors of equal value are in parallel means the total resistance will be R by 3. Okay, so that is according to the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. All the resistors are same, so it is 1 by R plus 1 by R plus 1 by R, which is 3 by R. But 1 by Rp is 3 by R. Rp will be R by 3 reciprocal. Okay, so that is how you simplify the circuits. We will go ahead with the topics. Next topic what we have to understand is DC sources. DC sources is responsible for supplying DC current or DC voltage to the circuit. And the examples are cells, batteries, solar cells, etc. And even regulated power supply in the lab also we are going to use for conducting experiments. You have seen cells and batteries which you use for various appliances in the house. Okay, so if it is a cell, you show it like this. It is a source of DC energy. You show it with one long line and one small line. Long line represents positive, short line represents negative. Okay, if these are connected in combination like this, then it is called as a battery. Even single cell is also called as a battery. So what are the types of batteries then? There are primary batteries and secondary batteries. Primary batteries are ones which cannot be recharged, like our AA battery, which you use probably for your alarm clock or for your wall clock. You put AA battery. Once it is done, its usage is done, you have to throw it. You cannot recharge it. While secondary batteries are those which can be recharged. Where do you think we use them? In your cell phone? Cell phone battery uses lithium ion. Lithium ion batteries are used there, which can be recharged again and again. Of course it also has certain age, but then it can be recharged. So those which can be recharged are called as secondary batteries, which cannot be recharged are called as primary batteries. Primary batteries examples are zinc carbon and alkaline batteries, and secondary batteries are nickel cadmium, nickel zinc, lithium ion. Okay, so this is what is extensively used these days everywhere. We want to reuse the batteries, isn't it? So those are the secondary batteries, and the people who invented these are given Nobel Prize. If you observed, 1 or 2 years back they received Nobel Prize for inventing lithium ion batteries, which are extensively used world over. That is why it has revolutionized the electronic appliances, just because rechargeable batteries are invented. Okay, so that's about batteries. If we talk about cells, again there are of two types, wet cell and dry cell. Wet cell, here liquid electrolyte is used. Okay, examples are Leclanche cell and Grove cell. This is in a container where it is liquid and two electrodes will be inserted, and from there connections are taken, and it is used for whichever appliance they need, and you cannot move it. This is not portable. Wet cell will be housed in one place because it is if it tilts, the electrolyte will spill. That is why it cannot be portable. Whereas dry cell is portable. You can move it, because here it is like electrolyte is like a paste, and it has moisture enough to conduct electricity. For example, nickel cadmium batteries or lithium ion batteries, which you use in your cell phone. These are all dry cells. These are the two types of cells. When you connect cells in series, you will get required voltage rating. If you want more voltage, you put more cells in series. But if you want more current, Then you put them in parallel. Cells are connected in parallel to get desired current rating. Okay, these are about the DC sources, cells and batteries. Now coming to electrical source, a basic definition of electrical source: it's a device which provides electrical energy to the circuit and is classified into two types: current source and voltage source. Voltage source is responsible for supplying energy in the form of voltage, whereas current source is responsible for supplying energy in the form of current. So now we will see how to represent voltage source. Ideally, how does it look? Practically, how does it look? And similarly, current source. So this is how it looks. Voltage source is represented as a cell, single cell only. And if it is ideal voltage source, it does not have internal resistance. Only voltage it will give at the output. So when you connect the load, entire voltage will appear at the load. So when you plot voltage versus the current, then it looks like this. No matter how the load is going to be, it will give you constant voltage. This is ideally speaking. It is not like this practically. Okay, so what does this load mean? You should understand this circuit like this. This is your battery. For example, in your cell phone you have battery, right? If it is a ideal voltage source, then if it is an ideal battery, your cell phone is this. Cell phone uses the battery. No, load is always application. It can be a cell phone, or it can be a keyboard, it could be a watch, where the cell is connected. So the battery is used by the cell phone, isn't it? For example, if you use cell phone for listening to the music, and if you are increasing the volume, that means more current is drawn. Okay, so that is how you are understanding here. You should understand here, when the voltage versus current is shown as a graph, when you're drawing more current, if you're increasing the volume more and more, what do you expect? Battery should give constant voltage. If it gives constant voltage, then you say it is an ideal voltage source. Practically it does not happen like that. This is a practical voltage source which has its own internal resistance. And when you connect the load, this is your cell phone battery, it comes with internal resistance. Your cell phone battery is a practical voltage source, it has its own internal resistance. So when you start using the battery in your cell phone, when you increase the volume for whatever reason, that means you are drawing more and more current. When you are drawing more and more current, it is supposed to be like this, but it will not be like this. It will continue to reduce. The voltage that is supplied by the battery continues to reduce as you increase the current. This is the practical voltage source. Okay, so practical voltage source has internal resistance in series. This is the voltage source with the series internal resistance is called as practical voltage source. Let us see how the current source is denoted as. Current source you have to show with a circle and an arrow mark. This is the ideal current source, and the ideal current source's job is to supply current to the load. Okay, energy is supplied in the form of current. Now ideally speaking, there is no internal resistance. It is open circuit, means it provides infinite resistance. In ideal voltage source, if there is no internal resistance, means it is equal to 0. Whereas in ideal current source, if there is no internal resistance, means it is equal to infinity, because it is considered in parallel. Okay, there it was considered in series. So practical current source will have a parallel resistance, internal resistance with the current source. So ideally speaking, this will be infinity. Practically it will have some value. Okay, now we will see how to convert practical voltage source to practical current source. Conversion of voltage source into current source. This is the voltage source, this is the current source. Now the internal resistance remains the same, that doesn't change. Okay, RS is going to be RS. How to find IS? Using Ohm's law. Simple. You know that I is equal to V by R, right? So to find IS, all you have to do is Vs by Rs you have to do. That is going to be your IS, and you write the value IS. And how to convert now current source to voltage source? Similarly, if this is a current source given, if you have to convert it into voltage source, IS is known, RS is known, RS remains the same. You don't change RS, you just write the same value. To find Vs, use Ohm's law. V is equal to I into R. So this into this will give you Vs. See the equation. Shall we take example now? We'll take an example to convert current source to voltage source. Current source has the value 5 amps IS and internal resistance is 2 ohms. You should know to draw the voltage source with the internal resistance in series. How to find voltage source Vs? Vs is nothing but I into R. 5 into 2 is going to be 10. See the equation. Internal resistance remains the same. You just have to write the same value. Okay. Other way around, if at all, imagine they have given voltage source and you are asked to convert this into current source. How to do that? First you should draw the circuit diagram like this. Current source in parallel with resistance. Resistance you write the same value. To find 5 amps, what do we have to do? All we have to do is use Ohm's law. I is equal to V by R. 10 divided by 2 is equal to 5. You just have to write that. That's all. You can convert current source to voltage source or voltage source to current source. This will be asked for 2 marks. Next we will go ahead with the next network theorem. First network, not network theorem, this is another law. This is Kirchhoff's law. Ohm's law, you know, V is equal to IR. It is applicable for simple circuits. For complicated circuits, it is not enough. We also have to use what are known as Kirchhoff's laws along with Ohm's law. Okay, so even before we talk about Kirchhoff's laws, you need to know certain terminologies. So we will just go through all these terminologies and then state Kirchhoff's laws. Okay, so this is a typical network or a circuit diagram. There are 4 resistors connected and with a voltage source, and I have called this as A, B, C and D. First term is node or junction in a circuit. Node or junction in a circuit is a point where current divides. Where does the current divide? From the voltage source here, it comes up till here and it gets divided. And this current goes and comes here, and this current comes down here and it gets joined. So nodes are B and D, where it gets divided and also divided current gets joined. Okay, so node or junction is a circuit where current divides. Node B, node D. Next, loop. It's any closed path in an electrical circuit. Closed path like this. Current will be flowing here, current will be flowing here, or current also will be flowing here. So which are the closed paths then? A, B, D, A, B, C, D back to B, and A, B, C, D back to A. Those are the loops. Mesh is an independent loop. It does not have loop within it. Now loop can have meshes within it. See, this is a loop, big one, which has 2 loops in it, whereas mesh is an independent loop. That means this is one mesh, this is one mesh. This cannot be a mesh. It cannot have 2 meshes in it or loops in it. Okay. Next, branch. It's a conductive path through which same current flows. In our circuit, DAB is a branch. This is one branch. BD is one branch. BCD is one branch. So this particular circuit has 3 branches. This is one, this is one, this is another one. Okay, go through several times until it registers in your mind. Next, what is a linear network? Linear network consists of linear devices such as resistors, where current is proportional to voltage or voltage is proportional to current. You know that. So this circuit where only resistors are there, they are called as linear circuits. Non-linear network is network or circuit which has non-linear devices where current is not proportional to voltage. Where it is not proportional to voltage, remember non-ohmic devices, diodes, transistors, etc. are non-ohmic devices. Such circuits are known as non-linear networks. Such networks where diode, this is a symbol of diode. If diode is there, then it becomes a non-linear network. Next, bilateral network. Here, relation between voltage and current does not change for two possible directions of current. Means if the current is flowing in this direction also or this direction also, values will not change. It remains the same. Such circuits are called as bilateral circuits or networks. In unilateral network, relation between voltage and current changes for different directions. If the direction of current is like this, the relation between voltage and current is going to be 1, and if it flows in the opposite direction, it is going to be different. So such circuits are called as unilateral network. The circuits current in one direction equation is 1, in another direction it is going to change. So wherever diodes and transistors are there, it's going to be like that. Okay, these are the important terminologies. We will be using them. You should understand what we are talking about when we use such terms. Okay, now we will see what is a Kirchhoff current law. First we will take Kirchhoff current law and then we will take Kirchhoff voltage law. In short, it is KCL, or it is also called as node rule. Algebraic currents at a node in an electrical network is 0. This is a statement. Or another statement is sum of currents entering a node is equal to sum of currents leaving that node. If you consider a node in this circuit like this, if A is the node, I1 is entering, I2 is entering, I3 is leaving, I4 is also leaving, seeing the direction. So according to KCL, sum of currents entering is equal to sum of currents leaving. Okay, if you apply KCL at A, which all are entering? I1 and I2 are entering. So I1 plus I2 is equal to I3 plus I4. This is the equation. Sum of currents entering is equal to sum of currents leaving. That's all. Okay, for example, I have taken example. If I1 is 1.5 amps, I2 is 2.5 amps and I3 is 0.5 amps, how to find I4? According to this equation, I4 is nothing but I1 plus I2 minus I3. So substituting, we will get I4 as 3.5. Sum of these two should be equal to sum of these two. We can cross verify. I3 plus I4, I3 is 0.5 plus I4 is 3.5. Together it is 4 amps. Is this equal to I1 plus I2? What is I1 plus I2? 1.5 plus 2.5, that is also equal to 4. So 4 is equal to 4. Sum of currents entering is equal to sum of currents leaving. This is KCL. Very important. We are going to have an experiment in the lab also on this, and it's very important, keeping second PUC also in mind. KCL and KVL, we use it extensively. Next we'll see what is KVL. It's also called as Kirchhoff's voltage law or loop rule. KVL states that algebraic sum of EMFs in any closed loop or a network, in a closed loop of a network, is equal to algebraic sum of IR drops in that loop. If this is the loop, sum of EMFs, electromotive force, means voltage sources, sum of them is equal to sum of IR drops, I into R drops. What is the current flowing in this? I is flowing, IR1 is the drop, IR2 is the voltage drop. So IR1 plus IR2 is equal to V in our circuit. So sigma EMF is equal to sigma IR. Applying KVL to this, we get V only one EMF is there. So V is equal to IR1 plus IR2. IR1 can be called as V1, IR2 can be called as V2. So V is equal to V1 plus V2. In other words, we can also say sum of voltage rises is equal to sum of voltage drops. That is also KVL. Always voltage source will give voltage rise. So sum of voltage rises is equal to sum of voltage drops. In this example, for example, V is equal to 20 volts and V1 is equal to 15 volts. Then what will be V2? V minus V1 will be V2. So substituting 20 minus 15 is equal to 5. So if this is 20, if this is 15, this has to be 5 because 15 plus 5 has to be 20. For example, this was 10. This was 10. What is this? 10 plus 10? 20. Like that. Sum of these two should be equal to this. Okay. So this is KVL and KCL and Ohm's law. 3 laws you have learnt up till now. We are going to use them for all our problems. So today's assignment is going to be these. You have to differentiate between primary battery and secondary battery. You have to give examples for wet cell and dry cell. With an example, show how a voltage source can be converted into current source, and you need to state KVL and KCL with relevant circuit diagrams and equations. Answer all these assignment questions in the assignment book only. Classwork is separate, assignment book is separate. In classwork, you write all the slides. In assignment, you answer all these questions. Okay, so this is about it. Please go through again and again until you understand. This chapter is very important, very basics. Again, all these are there in your second PUC physics also, and in your CET also all these problems will come. So understand the fundamentals properly. We will solve problems based on KVL, KCL in the next session. I'd like to leave you with this thought by Swami Vivekananda, great philosopher, who said, all power is within you. You can do anything and everything. Believe that. Okay? You have all the power within you. You need to know how to use your power. If you use it for the right purpose, it is going to be good. Otherwise, you know how it is going to be. Okay? With this thought, I'll leave you guys. Please learn, and I'll see you in the next session. Take care. Thank you.